Hello, and welcome to today's ACM Tech Talk. This webcast is part of the ACM's commitment to lifelong learning and professional development, serving the global membership of computing professionals and students. I'm Will Trace, Lockheed Martin Fellow Emeritus, former chair of ACM SIGSOF, and a member of the ACM Professional Development Committee. For more of my background, see the bio widget on your screen. For those of you who may be unfamiliar with ACM or what it has to do and offer, here's some more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in a constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. You can see more of the highlights on your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in a global environment. ACM provides access to the ACM Digital Library, the world's most comprehensive database on computing literature, leading publications and global conferences that draw top experts on a broad spectrum of computing topics. I'd like to point out that the International Conference on Software and Engineering is currently taking place, and you can still sign in as a virtual attendee. If you're a student and a member of ACM, it's only $32. If not, it's $38. If you're not a member of ACM, it's $62 as a professional, or $50 if you're a member of ACM or SIGSOF. And SIGSOF membership's $20 if you're a professional, $10 if you're a student, and it entitles you to many of the ACM SIGSOF conferences. Besides, there is support for education and research, including curriculum development, teacher training, and the ACM Turning and ACM Prize of Computing Awards. Finally, the ACM Code of Ethics, a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions in professional practice. ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. Before we get started, I'd like to quickly mention a few housekeeping items shown in the slides in front of you. For those of you joining us for the first time, if you have questions at any time, please type them in using Zoom's Q&A feature. I'll organize these questions as Adam speaks, and we'll try to get to as many as possible. This session is being recorded and will be archived. You'll receive an automatic email notification when it becomes available, and check learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey opened on your screen. Please take a minute to fill it out and help us improve our tech talks. Today's presentation is Lessons from the 50-Year Quest to Turn Programmers into Software Engineers by Adam Barr. Adam Barr worked as a programmer and manager at Microsoft for more than 20 years. He is the author of Find the Bug, Proudly Serving My Corporate Masters, and The Problem with Software: Why Smart Engineers Write Bad Code. Adam now works at Crosslake Technologies as a software consultant. Adam, without further ado, take it away.
Okay, thank you. Let me just share my slides here if everyone can see that. So this is about my book, The Problem with Software: Why Smart Engineers Write Bad Code. I didn't want to insult the engineers directly since I am a software engineer. So the engineers are smart. It's just some problems with how they create the code that we're trying to address. Quick background on me: I worked at Microsoft for 23 plus years, as Will said. Worked on the first two versions of NT and then Windows 2000, also 2 versions of Office, and on Microsoft PowerShell, which is a scripting language, and also some time in an internal training group inside Microsoft. And now I work for Crosslake doing consulting. So in Microsoft, I saw a very in-depth view of how Microsoft develops software, but now at Crosslake, I'm seeing a bunch of smaller companies. And it's been quite interesting to see the broad scope of software development techniques that are in use. The term software engineering originated, at least in mainstream use, in a conference that NATO put together in 1968. That's where the 50-year quest comes from. And the first conference was in Garmisch, Germany, there on the left, and there was a second conference in Rome a year later. Someone actually commented that Margaret Hamilton, the well-known developer who managed a team working on the Apollo software, actually coined the term software engineering earlier than that, but this is the first time it was sort of widely used. So in the notes for the second conference, after the Rome conference, Buxton and Randell, who edited the proceedings, commenting on the first conference, said there was a wide range of interests. You had the spectrum, academia, and people on the firing line, people in industry. And they all agreed that there was a serious problem with software engineering, and they had a very productive series of discussions. So they said, great, we'll have the second conference to discuss this and try to solve these problems. So they had the Rome conference a year later. They said they still had the same broad range of participants, but it bore literal resemblance to the first conference. They didn't have the sense of urgency to solve the problems. Instead, they had a lack of communication between the industry people and the academics. And that became the key takeaway. That communication gap was the key takeaway from the second conference, just as the fact that there was an issue was the key takeaway from the first conference. And unfortunately, that was the end of the NATO software engineering conference series after 2 years. And this gap persists today. That is the fundamental problem with software, that what you learn in school and what academia is focused on is not what industry is interested in for software development. And what is the cause of this? This is from an essay by Fred Brooks. Fred Brooks is best known probably for his book, The Mythical Man Month, and the essay, The Mythical Man Month, about how if you add people to a late software project, it makes it later. This is a different essay in the same book called The Tar Pit, which summarizes Brooks's view of the software industry at the time. And the key is differentiating between what he calls a program in the top left quadrant and a programming systems product in the bottom right. So program is what somebody works on, a team of a few people, where it's the same team works on it the entire time. Typically, the developers are the users of the software. And then this gets complicated in 2 dimensions. One is going to the right as software is stitched together from multiple teams. They have to coordinate on it. And then more complicated as you go down over time, as the original authors of the software are no longer working on it and new people become involved, and you have to worry about maintenance and documentation. And then you put those together and you get a programming systems product, which is what industry does. They write software that lasts for a long time and is written by multiple teams and stitched together. And academia focuses on the top left, and industry is doing the bottom right. And I'll use those terms, top left and bottom right, to distinguish between programming in the small and programming in the large. In this essay, Brooks says that it's 3 times more complicated in both dimensions. So the bottom right is 9 times as complicated as the top left. Edgar Dijkstra, another computer scientist famous for generating good quotes, said that he feels the difference, he'd like to be able to talk about a small program and then say, well, a large program is just the same thing, more of it, but he says it just doesn't work. One of the central themes is that they differ by a factor of 100. So he thinks it's 100 times more complicated to work in these large pieces of software. And you just can't use what you learn in the top left to inform what to do in the bottom right. And Harlan Mills, who was an IBM research fellow, also on the faculty of several universities and has an IEEE award named after him, similarly commenting back in 1980, it's characteristic that the problems to be solved by advanced practitioners, meaning industry people, require sustained efforts over months or years from many people. So again, talking about the bottom right quadrant. This kind of mass problem solving requires a radically different kind of precision and scope in techniques that are required compared to the individual problem solvers. And individual problem solvers, I would lump together small teams in a school project, for example, for one semester with 2 or 3 people, or what a professor and a few graduate students can work on. Those are still top left problems. One area you can see this is in who is creating programming languages. So initially, the first few languages were created by academia. BASIC, Pascal, and ALGOL, because the scope of problems that academics were looking at in the 1960s was similar to what industry was looking at. They were still fairly small. Then you got into research labs, creating languages. So Simula out of a Norwegian lab, C and C++ from Bell, and Smalltalk from Xerox PARC, where they felt the languages that existed were not enough to solve the problems they were tackling as they grew in scope. So they started creating these languages, not as a product itself, but to solve some other problem. And then you got to the stage where companies were creating languages as a product to sell. So Objective-C and Eiffel in particular, the first two object-oriented languages to be pushed this way. And then Microsoft with C#, Java at the beginning, and other languages. They were products. And this led to a certain amount of hype about how useful they were and how broadly they could solve problems that was not backed up by any academic research. People were just making claims about this stuff. Now, we actually returned a bit to the research lab-ish focus today, where languages like Go coming out of Google are not a product. They're just something that Google created to solve problems, and they have a little less hype. But still, there's no sense of Go is useful for this problem and this other language is useful for this problem. People just learn a language and try to use it everywhere. And if you've ever tried to maintain a large Perl code base, for example, you'd realize that Perl is a very good language for top left problems, but it runs into some issues in bottom right quadrant problems. But people don't think about that. They just use it everywhere if they like Perl. So Fred Brooks wrote an essay, another essay called No Silver Bullet, referring to the Lone Ranger using silver bullets to shoot his enemies. And he says, we hear a desperate cry for a silver bullet, something to make software costs drop as rapidly as hardware costs, which we're dropping. And this is in 1986. He says he sees no silver bullet, no single development in technology or management that will give us this rapid improvement. And the key thing he says is not only are there no silver bullets now, but he doesn't think there ever will be any. Something about the nature of software will prevent there ever being a silver bullet. This is back in 1986. Nonetheless, over 50 years, there have been many silver bullets proposed. This is the thing that will make software simple and avoid all the problems we have with creating reliable, maintainable software. So starting with structured programming back in the 60s and 70s, this essentially is, can you write code without go-tos, which is, I think, accepted today, but was actually somewhat controversial. And there's a lot of a push for structured programming, even though people couldn't really define what structured programming was, but it was clearly better than unstructured programming. Then you had formal testing, maybe that's the answer. Object-oriented programming came along, as I talked about, and design patterns, unit tests, TDD, agile, all that pile of stuff. Again, presented as this will make it easier and easy. And now we have functional programming, DevOps, DevSecOps. Again, these are not bad. These are all improvements in software development, but they're not silver bullets. They're not the one magic thing, which is often how they're presented. So looking back, looking back at structured programming, there actually was an academic proof back when academia was thinking about this kind of thing, the Bohm-Jacopini theorem, that you could write code without go-tos, just to demonstrate that it was possible. Then look at formal testing. At least academia and industry are both thinking about this. Dijkstra and Mills, that's an academic and an industry person, both commented that you could not test quality into software. They're both thinking about this problem. Now, in this particular case, companies like Microsoft then proceeded to ignore this advice for 20 years and tried to test quality into software, but at least academia and some people in industry were thinking about the same problems. And then you get into what you might call the hype phase. So this is from a book about object orientation, whose author I have withheld to protect them, the guilty here. This just talks about XP and Agile and objects. It solves all problems and it completely changes your worldview. You can focus on the problem space instead of the solution space, whatever that means. He name drops Plato. And it just goes on like this for hundreds of pages with no actual data or research showing that this is true. He'd just talk about how great it is and it's a silver bullet. And this is object-oriented programming. It's useful, but fundamentally it's just, let's have methods where the local variable values persist across method calls instead of being reset every time you enter the method. That's what object-oriented programming is. Fundamentally, it's useful. It's very useful, but it's not magic, and it doesn't change your worldview the way this person is claiming. Again, as I said, these are useful. The idea that dev would throw things over the wall to test was not good, so put them together in engineering. Engineering throw things over the wall to ops. That's not good either. Create DevOps. DevOps throws it over the wall to security. That's not good, so we'll have DevSecOps, and I'm sure they'll find somebody to throw the problem over the wall to. These are all improvements in software engineering, but not magic, and they're not silver bullets. The other thing is people used to study programmers empirically. This is actually coming back, which I'll talk about towards the end, which is good. But people used to study questions like, what are the right format for comments? Are comments good? There was actually debate about whether you should have comments at all. Variable names, people actually, again, debated, should you have clear variable names or not? Because there was some theory that unclear variable names required you to understand the program more deeply. Indenting, go-tos are go-tos sometimes useful, even if they're not ever required. These were studied. People would do controlled experiments, have groups of volunteers try to understand code, but this sort of died off. And Fred Brooks, in the 20-year anniversary edition of Mythical Man Month, looking back, said he was surprised by how few of what the claims he made were actually critiqued, proven, or disproven by actual research, people actually studying this stuff formally instead of just complaining. And he goes on to talk about people attacking the central argument that there is no magic solution, no silver bullet, and there can't be one. He said most people agree with that, except they say there is a silver bullet. It's the thing that the person who's talking to him has invented. So if you just understood my brilliant idea, then software would be easy. You just missed it. And that's fairly typical software developer attitude to say, yes, well, I know how to do it if everyone would just see my brilliance, even though they didn't have any research backing up their claims either. So it's Harlan Mills. Again, this is not new. Harlan Mills commenting on this a long time ago. Says there's no mathematical rigor. So these became quite vehement arguments. People sometimes use the term religious arguments to talk about these in software. This still is from this show Silicon Valley, where Richard is breaking up with his girlfriend because she uses spaces instead of tabs to indent her code. You just can't imagine a life with someone like that. Personally, I agree with her, but well, again, I should stay away from giving my opinion on these kinds of arguments. And this is a comment from an unidentified Windows NT developer in 1992, which was not me, even though I was an unidentified Windows NT developer in 1992, saying coding style wars are a waste of resources. This is the argument between the Office team that used a notation known as Hungarian for variable names and the Windows team, which used a different style. So the person admits that it's silly to have these discussions, but they can't resist getting in this dig that the other person is wrong and Hungarian is bad. Even today, this is from an article this week about Elon Musk open sourcing the Twitter code base, but the comment is added, well, code is typically hard to read even by those who have written it. So it's now just become a throwaway line that software is hard to read and programmers don't worry about maintainability and all that. So what happened? How do we go from industry and academia being somewhat aligned and trying to work on the same problems and academia focusing on industry problems to the current split? So Gerald Weinberg, another longtime observer of the industry, back in the mid-90s, was looking at a team and he says, it's a coincidence that all of them had learned to program before they studied programming formally in school. And that's a change from his life, where he didn't see a computer until he started working at IBM in the 1950s, or people in the 1960s and 70s who didn't have access to a computer until they went to school, at least. He calls it a coincidence, but it's not a coincidence. It's the problem. And this is Paul Allen and Bill Gates back in high school, working on some terminal system. And of course, they then founded Microsoft, and Microsoft was founded to create BASIC. And BASIC became the dominant language on personal computers, which started arriving in the mid-1970s. Because they had so little memory, they needed an interpreted language that could run in 4K or 2K or 1K of memory. So something like algol, a compiled, more sophisticated language, just wasn't going to work. And so BASIC won, and all these people taught themselves to program at home using BASIC, which is a terrible language for bottom right quadrant development, even though it's fine for top left. I actually once got into an argument with my sister, who had taken a Pascal class in college, claiming, oh, I don't know why you need these named methods and local variables. I'm doing just fine with my basic programs with random go-tos and subroutines just identified by number and no local variables, because I was completely thinking of the top left quadrant. That's all I had in my experience. Dijkstra, another famous quote, says that it's impossible to teach good programming to students that have had a prior exposure to BASIC. As potential programmers, they are mentally mutilated beyond hope of regeneration, sorry. So that's me, early exposure to BASIC. Hopefully I've somewhat survived it. But his point, he wasn't just criticizing BASIC for no reason. He was saying you should work in better languages like algol in particular that had come out recently, which had local variables and named methods and so on. He was trying to stop people from moving to BASIC. Unfortunately, it was 1975, the year Microsoft was founded. The first PCs were about to come out, and it was too late to solve this problem. And everyone went off and learned BASIC and became self-taught and had this very top left focus in what they were doing. Harlan Mills, 50 years ago, pointed out that the curriculum in schools, he compares it to a course in French dictionary. This is talking about computer science education. They study the dictionary, they learn the meanings of, in this case, in the analogy, French words that match an English word, which is like learning the syntax of the language. And then they tell people to go forth and write poetry or code in the analogy. He said some people can write code and some people can't, but they weren't taught to write code. They were taught the syntax of the language, but they were not taught why you would use one language over another, or how to write maintainable code, or how to structure a large body of code, how to ensure it's reliable. And that's the experience I had, and it's the experience a lot of students still have. You do write a lot of code in college, but you're mostly focused on algorithms and not on this bottom right quadrant maintainability aspect of the code, because you're working in small teams and your work goes away after a semester. Now, there are some schools, most schools will now have a course. I know NC State has a software engineering course. Carnegie Mellon has a DevOps course, which is great, but it's typically one course among a bunch of others which are focused on language syntax and algorithms. And Harlan Mills, again, a long time ago, said, if this precision and scope are not gained in university education, it's difficult to acquire them later. And I certainly experienced this myself. I was a self-taught basic programmer. I went to college. I never really unlearned what I had taught myself about BASIC. And even after I started working at Microsoft, it took a while for me to realize that there are a lot of other things I was unaware of when it comes to writing software, because I was focused on the top left, and that was my experience. And I was now working in the bottom right quadrant. And so now we have coding camps. So coding camps are certainly as guilty of hype as any object-oriented book was, but they exist partly as this, okay, you can get into software and make a lot of money, but they partly exist because there is this gap. There is this gap between industry and academia that they're trying to fill. And some people actually say, you should go to coding camp, even if you have a CS degree. This will fill in the gap, because in addition to focusing on current tools and technologies, they also talk about things like unit testing and defining APIs and securing your application and using source code control systems, things that industry needs and that you need for bottom right development. So although it's easy to sneer at coding camps and say, yeah, they're just trying to make people a quick buck. They do have an actual real use, and they're filling a gap that does exist. And looking back at my college, 4 years of college as a CS major, how much time I actually spent in front of a computer programming, it was probably only about twice as much as I'd get from doing 3 months of coding camp, which is 9 to 5 at least, and every second you're in front of a computer. It really is quite dense in terms of instruction. So as I said, I'm not saying coding camps are a replacement for a CS degree, but they're certainly interesting, and there may be a bit of an innovator's dilemma situation where they become good enough to replace a CS degree. Eventually, there may well be 4 years of knowledge that you need to gain to be a software engineer, but it's probably not what you're getting in the current 4 years of majoring in CS. So questions you might think an engineer would be able to answer: what programming language should I use for this situation? I'm doing a code review, what should I look for? I'm hiring people, I want to see if software is reliable, this component I want to use is reliable. Should we extend this software? Is it about to fail? Is it obsolete? Since software is always extended until it falls over. You just don't know these questions. They're not studied by academia and they're not studied by industry. And programmers are just too content to use their current knowledge as a guide for the future. Whatever they've done that worked in the past, they'll just keep doing until something really bad happens. As Benjamin Franklin said, experience is a dear teacher, but fools will learn it no other. One of the most insightful quotes I ever got at Microsoft, we were studying teams that had moved to services from packaged software, which is a dramatically different approach. And someone who had worked on a service gave a whole bunch of great advice about the difference, and you had to focus on keeping it running versus just shipping it and forgetting about it. And then they said, but if I went back in time 2 years and gave myself this advice, I wouldn't believe it. I had to experience it myself. And this is sort of fundamental about software. People don't realize what they don't know about bottom right software development. And Gerald Weinberg made the same point, that it's important to have a little bit of humility. Otherwise, you're foredoomed to hubris, leading to blind self-destruction. This is Gerald Weinberg's style of writing, so he exaggerates things a little bit. But his basic point is true. You don't want to wind up like Icarus, the classic hubris situation where you fly too close to the sun and wind up drowning. And I love this quote from Lex Ohanian, who founded Reddit, but he's also married to Serena Williams. And he says, I thought I was the hardest working person on the planet. I thought we were the hardest working industry. It's all malarkey. Watching Serena Williams actually be great has taught him how hard you really have to work to truly consider yourself great. And Harold Mills, again, almost 50 years ago, makes the point, it all happened so fast that it's been one generation from his perspective that this has all happened. There hasn't been time for the expansion of useful methodologies and pruning of less useful topics. Now, the people Harold Mills was talking about are no longer in the industry, but the self-taught basic programmers like myself are still around running software companies. It's as if Orville Wright were running Boeing and saying, gee, I don't know about those newfangled jet engines or something, right? Because when I was flying, we did whatever. And that situation is really happening at companies today still. The Orville Wrights of the world are still running software companies. And one thing that the old school people tend to focus on is performance. So Donald Knuth, another well-known computer scientist, has this famous quote, the grail of efficiency leads to abuse. Programmers waste enormous amounts of time thinking about or worrying about non-critical parts of the system. And more importantly, it's not just that they waste time, it has a negative impact on debugging and maintenance. This performance work makes the software worse, not just have no useful effect. So he says, forget about small efficiencies. We should just not do them. And his famous quote is, premature optimization is the root of all evil, because optimization is a top left activity. You can do it by yourself and see results by yourself. Whereas worrying about integrating with other teams' code and the long-term documentation maintenance involves other people, and programmers are not huge fans of working with other people. But performance and reliability are enemies, and trying to make your code more performant will make it less readable, less maintainable. And almost every exploit I saw at Microsoft was the result of somebody taking a shortcut in the name of performance, not checking some variable, not doing some step, or just fundamentally using a language like C for network-facing code because it was faster, and refusing to even use a string handling library, which might avoid some of the overruns because they want to tune it as much as possible in the name of performance. And I'll just take out the word premature from Knuth's quote and say optimization is the root of all evil in software. Not that you should never optimize. This is based on the quote, money is the root of all evil. Not that you should never use money, but be careful. It is typically the cause of problems. So can we get back to this happy land of top left software that we enjoyed writing when we taught ourselves to program, or when we were in college working on these little projects? And it can all be fun again. And the answer is no, you can't. If you want to be a professional software engineer today, you have to do all this extra stuff. As Harlan Mills again said, the next generation has to be much more competent. They just have to be. It was easier to be a programmer in the old days, but you need this level of precision and productivity. Now, we are better. All those silver bullets, although they're not magic, they do make software better. We have better tools, we have better techniques, but we still have a ways to go in formalizing all this. And there still is the industry academia split. Luckily, services are making things better. Cloud services, because now you can write software that is split into pieces with nice clean APIs, and they can be tested rigorously on their own and stitched together cleanly. You can even write different components in different languages. If you can figure out the appropriate language for different kinds of code, you can use different API styles if that works. And this is getting much closer to actual software that's engineered, and you can make statements about the reliability of it. And we could get closer to what engineers can say in other disciplines where how strong is this? Is it about to fail? I want to make it twice as strong. You could do things like that. Even performance, if you want to improve the performance of a service like that that's written cleanly, you can throw money at the problem initially and just scale up your service. And if you have to make coding changes, you could do those later rather than in some crisis. And if you're working at a company and you're saying, I don't have time for this, I'm in a hurry, I have to get my MVP version out. And we see this a lot working for Crosslake. The companies have taken shortcuts, they haven't done unit tests, they don't have good documentation, they're not worried about security. It becomes a huge issue. We're looking at companies that are potential acquisition targets. And if we see that their quality is bad and they haven't done the proper engineering, that's a very big negative in the report. And in some cases can mess up an acquisition and prevent someone from wanting to acquire them. So my advice is just do this from the start, set up an environment, run your static analysis, do code reviews, create unit tests. If you do it all from the beginning, you won't notice it as an overhead, but if you have to suddenly tackle it after you've written a lot of code, it's a huge, huge pain to do, and a lot of people just can't do it at that point. As it said in The Lord of the Rings, shortcuts make long delays. So the good news is empirical studies are coming back. This is just a sampling of recent papers on empirical studies. So looking at error reporting, the existence of large code repositories is great. Large open source repositories is fantastic for empirical studies because you don't have to watch the programmers work in the top left quadrant. Essentially, you can look at the result of bottom right quadrant development, check into a repository. So looking at code quality, this notion of naturalness, that if code is written in a certain sort of common style, it becomes easier to read and also less buggy. There's conferences focused on this. So the Empirical Software Engineering and Measurement Conference, ESEM, sponsored by the ACM and IEEE. And then the ICSE, as well mentioned, which is happening right now, also ACM, IEEE, and the related Program Comprehension Conference and the Mining Software Repositories Conference, which are also co-located with ICSE, are great sources of insight. Now, these are academic papers being presented. They're not as neat and as a book on extreme programming or DevSecOps. A lot of them will say, well, more research is needed, that sort of thing. But that's the nature of this. It's ongoing work, but they're also free of the hype of those other things. They're not claiming to be silver bullets, which I think is refreshing. And there's a few journals, the Empirical Software Engineering, and then Software Evolution and Process. The Springer and Wiley journals are all about empirical studies, and then the main transactions from the IEEE and ACM also have occasional articles about empirical studies, which is great to see. Although it's not always crossing over into actual development, even at Microsoft, which has a research team which is heavily involved in empirical studies, not a lot of that wisdom is yet crossing over into the product teams that are working on the actual software, but at least the knowledge is out there somewhere. So I encourage you, of course, to get involved with the ACM. You're at an ACM talk, thank you, and the IEEE Computer Society. I'll finish with just a little bit of advice for people in different stages of their career. So if you're managing a team, the big thing I'd say is make sure you allow your employees the time to follow modern software development practices. Your instincts on how long something should take may be wrong because of your experience 20 or 30 years ago when you weren't writing unit tests and you didn't have to worry about writing scalable services. And reward people for doing that work up front. Don't reward the hero behavior of somebody who comes in and fixes a problem that was caused because you weren't doing the engineering up front. That is going to drive the wrong behavior. If you have a feeling, which I sometimes had, that wow, this is all new stuff and the industry has passed me by a little bit, you can become wiser. You can learn. You can always learn more about software development. There's a lot of new knowledge out there. If you're a senior developer or architect, you're setting the technical standards for a team. Establish some mandatory process. As I said, it's much easier to do static analysis, unit tests, things like that, if you just always do them from the start than trying to throw them on at some point later. Don't believe the silver bullets, but they are useful, so you can read about them. They're just not magic. Don't pick one thing and say, if we just do this, then it will be easy. I encourage you to read empirical studies papers rather than trendy books on whatever new technique is out there. And don't be that grumpy old performance-focused person. There are still Microsoft old timers who say, the kids today, they use C# string manipulation and they don't realize what's going on under the covers and how inefficient it is. And I think that's fantastic because they also don't have exploits in their string manipulation code like the code that the grumpy old timers wrote 30 years ago did. If you're a developer, just any random developer looking to improve, I encourage you to look at open source projects because they're a great source of bottom right quadrant development, especially large ones that have established rules and processes. And even if you don't contribute, look at the code, understand the rules and processes, why they exist, and you can learn something about how bottom right quadrant software can work well and the development processes that work well. If you're out of college, first of all, thank you for coming to an ACM talk. I think it's great if people get involved with ACM and IEEE as soon as possible. You may feel a weird mix of imposter syndrome where you realize you have this big gap between what you learned in college and what you need, but also knowing more than your coworkers because maybe you did have a class in DevOps, or you do know something about web development that they may not know. But my advice is whatever team you're on, you will learn something about the development process because you will be doing bottom right quadrant work rather than top left stuff you likely did in college. Even if what you realize is this is a terrible way to develop software and I want to work somewhere else, in a couple of years, you will gain valuable wisdom. And the imposter syndrome, I think a lot of people have that. It's just common. I gave an earlier version of this talk and somebody said, oh, we were just told in college that we weren't being taught what we needed, which I guess is good, but it's also bad in a way. If you're interviewing developers, don't focus only on top left quadrant, in particular algorithm stuff, things you can just do. Now, whiteboard coding is of necessity top left quadrant, and it's fine to ask a coding question, but don't be looking for a specific algorithm. I noticed that in Microsoft interviews, people would say, well, they solved the problem, but it wasn't the optimized algorithm. And that's what all they were worried about was the algorithm. You're worried about the code. If someone comes up with a super clever algorithm, it's probably so clever that the next person to work on it will break it. So it's much more important that the code is readable and maintainable. And if you want to talk to people about the code that they wrote, talk about how they would test it, how they feel about the variable naming, questions like that, how maintainable it is. Don't just focus on the algorithms. If you're teaching developers, the professor perhaps, I would say have your students read more code. There's a ton of open source out there, and reading code, I think, is critical. A lot of software engineering should be based on reading code, studying code, not algorithms and language syntax. You're going to write code, you should read code, good code, bad code, code that was exploited, code that's lasted a long time. There's just a ton of knowledge out there, and it's a way to prepare people for bottom right quadrant development, even if you can't actually really do it in an academic setting. Look at empirical studies, ideally conduct some empirical studies, even just using students studying themselves, how they feel about code, whatever, commenting, indenting. I mean, it's still valuable to get thinking about that there's different ways to do things. And don't ignore coding camps. They may become your competitor at some point because they are more focused on what industry wants. And if you want to do a little reading, these are the main books by Mills, Brooks, and Weinberg. They're old books, but unfortunately, what their wisdom is still very relevant because not a lot of this has changed. And that's why all my quotes are old in this talk, because I'm trying to show that, unfortunately, we're still stuck with a lot of the same problems. Dijkstra has some good books too, but his tend to mix together insights on engineering with a proof that a certain sort algorithm is faster or something like that. So it's a little harder to recommend one, but these three are all great and are still often recommended by people, which is good to see. With that, I'm done with my slides. I'm happy to take any questions. Will has said he was going to coordinate feeding me questions, so take it away, Will.
Well, thanks, Adam. Let's move on to questions and answers. I must say that I am somewhat overwhelmed, but it's because I've been looking at two feeds. One is the chat session, which is extremely interesting, that everyone agrees that it was a great presentation, and the chat session has a fascinating spectrum of opinions. And so I encourage you, Adam, to we'll summarize that and send it to you, because it once again reflects on the level of sophistication and experience of the audience. So I thank you all for sending in questions. And now I'm over 30 questions that I was able to somewhat summarize. And I will just randomly, I guess I have a broader question, the submitter said, around how can academia remain relevant going forward?
Well, I think to remain relevant, as I said, they need to focus to the extent that they can on bottom right quadrant. So look at open source projects, modifying open source projects, I think would be a great kind of class. Focusing on things like unit testing, even using source code repositories, things like that, just doing more of the things you have to do when you're in industry, recognizing that in the end, a lot of the work you do will be smaller. It will only last a semester, but still there's a lot you could do that is sort of aware of what industry is doing and preparing students to say, yes, there's these different things you'll have to do, and talking more about maintenance and so on. And also, as I said, just doing empirical studies where possible, and then pushing to get those empirical studies paid attention to by industry. I don't mean to lump any quote unquote blame for this on academia. Industry is also willfully ignoring wisdom about how to write better software because they're busy shipping it and making money. So I don't mean to say this is all academia's fault or anything. The industry needs to pay attention to what is being studied as well. But certainly having the knowledge out there and preparing the students for what they'll be involved with would be a good start.
Thank you. Now, I just wanted to, Adam, I'm going to read two quotes that once again surface in the chat room to see if you agree with it. Good programmers learn from good programmers. And the second one, start your career with bad programmers and you're lost?
I don't know if story, I mean, I guess good programmers learn from good programmers, and certainly there's, especially as software is not a pure engineering discipline, there's a bit of a craftsmanship approach. So yes, you learn from good programmers. I was fortunate early in my career to wind up on the NT team run by Dave Cutler, and who had a fairly good process for the time for trying to ensure quality software. I don't know if working with bad programmers necessarily disqualifies you from ever being a good programmer. In a sense, a lot of us started with bad programmers because we taught ourselves to program, and we were probably a bad programmer at the time, and we were just reading the syntax of the language. So there is value, as I said, in working in industry in almost any environment and getting code working and having customers and fixing bugs. So I think Dijkstra's quote about mental mutilation, because you programmed in BASIC, you could, I guess, extend that to say any bad programming situation. But I don't think that's true. I think you can learn something from almost any situation, but as long as you're aware that this is not a great environment, and you don't think that this bad environment is the way it's done, which unfortunately a lot of people might wind up with it. They get their first industry experience and they think, well, that just must be the way you do it.
Okay, now I'm going to open up Pandora's box a bit. Should we have qualifying exams for software engineering, just like civil engineering?
So absolutely, we should have qualifying exams for software engineers, just like civil engineers, but we should not have it today because we're not ready. So I think it would be a great goal to say in 10 years, although you could have said this at any point, any 10-year horizon in the last 50 years, but let's say in a certain number of years, we will have licensing and we'll have some sort of qualification, and the schools can teach to that, and industry can rely on that when they're hiring. But we are just not ready right now. There's not enough agreement on what should be taught. There have been various initiatives. Steve McConnell wrote a book over 20 years ago about this. And a lot of it is people saying, well, it's sort of a silver bullet. If people just learn this, if everyone just used agile or whatever, if we just license that would be the answer. But right now there's just not enough agreement because there's not enough knowledge, there's not enough research backing it up to say this is the corpus, this is what we should teach people. So the answer is yes, as I said, but not right now.
Good. Now, since I'm a used program salesman from going way back, I have to ask you a question about code libraries. And will we get to a point where lower level libraries are so stable that they cover so many use cases that we need minimal first party code?
I mean, I think we're getting to that. We certainly have the companies I look at for Crosslake, that are a lot of them are doing websites, web development. It's amazing how much of what they do is stitching together open source components and making them work. And a lot of them are reliable. The problem is you occasionally get issues. You have the log4j issue, which was an exploit in a widely used piece of code. And the problem is it's hard to know, is this actually reliable? Can I take a dependency on it? People have various ways to judge, is this an actually maintained open source library? Does it look like bugs are fixed? How old is the oldest bug? How many contributors are there, to get a sense that, well, this thing is probably in pretty good shape because a lot of people have worked on it and they would have noticed bugs. But unfortunately, the many eyeballs theorem of open source, which is that if a bunch of people can see the code, they'll see all the bugs and there won't be any security issues, is proven not to really be true. You still need unit testing and static analysis and all these other things. So ideally we get to a stage where you could say, I see this library, and it's not just that it's used by a lot of people, but the artifacts are there that say, yes, look, here's their unit test coverage, here's the static analysis results, and whatever else we can come up with to prove that software really works. And then you could reliably take these dependencies and say, yes, I just can, a lot of it's just knitting it together from different components.
Okay, combining two questions, what makes software engineering unique compared to other engineering disciplines, and what's your personal definition of software engineering?
Well, I think what makes it unique seems to be just the fact that there's no physical restrictions. you can do anything. You can write any code. You could write things any way. You can write things in any language. You're sort of, there's incredible freedom, which people have taken advantage of. That just makes it hard to make statements about this is good and this is bad, because there's so much possibility. I think software engineering would be to define it, the state I'd like to see it get to is where you can create reliable software and you can make statements about the reliability and quality of the software. So you could say, as I talked about earlier, is this obsolete? Is it about to fail? What do we have to do to bring it back to being up to date if it's out of date? I think of civil engineering, looking at bridge design, let's say, people can say, okay, this bridge is about to fail, but if you spend this much money, it won't fail. And there's also certain processes. Engineers don't say, well, it's a little bridge, so I'm not going to worry if it falls over. They have certain standards they have to meet, and it's just understood that's what you do. So something like unit testing to me is just a basic component of calling yourself a software engineer today. And yet a lot of people don't write unit tests because you can. It's part of the freedom that software gives you. So I think just having that sense of reliability and being able to make statements about what you produce that are correct and defensible would mark it as much more of an engineering discipline.
Thank you. Can a computer scientist do an engineering job well?
I mean, I think they certainly could. I'm not, there's this question of, should we split out computer science and software engineering as majors, or should we have specialization within the discipline of security and performance and whatever? I think it's kind of related to what Harlan Mills said. Some people will be good at writing software. Some people will write clean code that's maintainable, understandable, and won't fall into the trap of over-optimizing just for whatever reason. And that's something about this Harlan Mills. Some people can write poetry in French once they learn French syntax, but not everyone can do it. So yes, computer science doesn't prevent you from writing good software. Getting a CS degree doesn't block you from writing good software, but it also doesn't particularly guarantee it either. And that's what I'm hoping we could get out of academia, that people would, it means something. Microsoft would occasionally hire a music major as a developer because they dabbled in software. And in a sense, that's great, but in a sense, it's very strange that you could actually be an effective developer having entirely taught yourself and not really leveraging a four-year degree. And that's somewhat what coding camps are feeding off of too.
Thank you. Would you speculate on the impact of functional programming and AI on the future of software engineering?
Well, so I confess I'm not actually a functional programming expert. I've certainly heard people claim that functional programming is a silver bullet, and there's certainly some aspects. A lot of bugs, a lot of the concern I have with object-oriented programming is actually hidden behavior that you can't tell, and functional programming avoids some of that. So again, in certain situations, it's good, but I don't know enough about to comment authoritatively. And then AI, I mean, I guess I'm a person who doesn't think that computers can ever become truly sentient. So I think AI is useful, but certainly there's a lot of advances you can make, or maybe machine learning is a better term, in syntax error detection, predicting code. I know Google, I think, claims that some percent of their code is written by AI. So I think it can be helpful, but in the end, I think there has to be a person that actually makes a decision about what the code does and whether this code is stable and what are the proper set of tests. You can help with some machine learning, but I don't think it would ever replace people, which is my general feeling about AI.
Good. Next question. How do you view how the software development process, agile, waterfall, et cetera, impacts software engineering? Is it complementary? Does it hinder software engineering?
Well, I think agile is good. I think, again, it's good. It's an improvement over waterfall in some situations. One of my concerns is agile is presented as the cure for all problems, where in some cases a waterfall approach is, and I don't know if a lot of teams really did pure waterfall, but something more with a sequence like that, rather than having a whole team together, can be better. So agile presented as a solution to everything is not a great answer, even though it may be more useful. And one of the biggest benefits of agile is just getting people closer to the customer. So the idea of a rapid ship cycle and a rapid feedback loop, which seems obvious in most industries, let's figure out what the customer wants and put stuff in front of the customer and use them to decide if they like something. But somehow in software, people initially didn't do that. So that part of agile is fantastic, but a lot of the specifics really depend. I know Microsoft, I was heavily involved in getting Microsoft Office to change from shipping every 3 years to every month. And it was nothing at all like what an agile book says. It was actually a ton of process and tools and very formal approaches to avoid breaking something and enable you to ship without a 3 or 6 month test pass. So the rapid ship cycle is good, but quote unquote agile is not a panacea for all situations.
Okay, sort of got distracted here. The chat session is once again extremely interesting. And I was going to save this to the end, but someone said pretty much the best talk I ever heard. Thank you so very much. So I would agree, many comments along those lines. And then there was a comment, our industry has been suffering from serial amnesia, and how can a student recognize bad code without seeing some? So let me jump ahead or backwards to your experience at Microsoft. How did Microsoft ensure the software they produced didn't end up unused, with respect to requirements discovery? Solving problems that didn't exist for users that didn't exist either. So in your opinion, does DevOps pay attention to all the problem space, or specs should be the ultimate source of truth to them?
Well, I mean, I think there's a few questions
buried in there, yes.
Together there. I mean, Microsoft certainly was guilty of shipping things that weren't necessarily what the users wanted. Notoriously, the third version of anything was the good one, because the first version was late and had to be shoved out the door. And then the second version was the one where you got to do all the things you had to cut from the first version. And then finally, in the third version, you could get some user feedback from the first version and actually make the software that people wanted. So that's one of the things I like about Agile, is just get it out there in front of people quickly. And Microsoft Office shipping every month has enabled a much more rapid feedback loop. So I think I forgot the second half of the question. I know there was.
It was about devs and
DevOps maybe. Yeah, I mean, DevOps to me is more about from the dev team getting the requirements by whatever method that happens, which is a whole other area. And many people say that's the problem with software. The essence of software books are really about how you get requirements in correctly and getting the proper user feedback. But I'm more focused on starting from there. You have to, the team is given a set of things to implement and how they implement it. And to me, DevOps is more about that. It's about making sure that the thing you write is actually operatable. And DevSecOps is about operatable and securable. And I think it's a great improvement to say, we're not just going to throw it over the wall and they're integrated. But I don't think, in my mind, DevOps is not really about requirements and getting customer feedback, except in a sense that if your software keeps running, I guess you can get more feedback. But I do think there's a split. Even Agile, there's a bit of Agile does two things. It's about getting rapid feedback from customers and also about the way you develop. But the part about the way you develop, daily stand-ups and short cycles, is a little loose from an engineering perspective. It sort of says, well, you'll just figure it out. But I think there are some things that should be more formalized that Agile just doesn't address. Agile initially was defined as it's only really for, I think the initial papers were small teams working on new versions of updates to software, not completely new pieces of software, using object-oriented languages. And now it's been expanded to all size teams working on new or updates and any kind of language, and even now is being expanded beyond software. And I think that's overdoing it, as often happens with these things. They have a useful application, but then they're for various reasons claim to be usable much more broadly than they may really be wise.
Well, I'm afraid we've run out of time. And I'd like to thank Adam again for his informative presentation and insightful answers to the many questions. I'd like to thank the participants for once again offering up those questions, and especially the thread in the chat room. So thanks for taking the time to attend and participate today. This talk was recorded and will be available online in a few days at learning.acm.org. You can find announcements of upcoming talks and other ACM activities at learning.acm.org and acm.org. And finally, please fill out our quick survey where you can suggest future topics or speakers, which you should see on your screen in a moment. On behalf of ACM, Adam Barr and myself will trace. Thank you once again for joining us, and I hope you will join us again in the future. This concludes the talk. Well, Adam, you have something else to say?
Oh, no, just thank you. Thank you for the ACM. Thank you to all the attendees. Appreciate all the questions, and very interested to see any further questions in chat, and you can contact me on Twitter or through the ACM if you'd like.
Okay, thank you once again.